Hello everyone, welcome back to my channel Polymath Learning. Today I'm going to start and make you understand about deep learning. So before we jump into the deep learning, let's do a quick recap of machine learning. In previous session, we have understood about how machine learning works, and I have also spoken about the algorithms, supervised and unsupervised learning. Depending on the types of data and problems, we use approaches like supervised, unsupervised, and understood about these type of learnings. What if the data become extremely large and complex? So that's where deep learning comes in. So let's explore how deep learning takes machine learning to the next level. So in today's video, we are going to understand one of the most exciting field in artificial intelligence. That's nothing but deep learning. If you have ever wondered how ChatGPT understands language, how Tesla car detects roads, or how your phone recognizes your face, the answer is deep learning. In this video, I will explain what deep learning is, how it works, why it's so powerful, and we will understand every component shown in this diagram. So let's get started, right? So deep learning is a subset of machine learning that uses artificial neural network inspired by the human brain. You can see the traditional machine learning requires human to manually identify useful features from data, where deep learning automatically learns these features by passing data through multiple layers of neurons. So these are the multiple layers of neurons. We have the hidden layers, input layers, generative models, and some output layers. I'll keep on talking about it. So the word deep means, when we say deep, what exactly the meaning of it? Simply means that the neural network contains many hidden layers, which you can see on the screen. The more hidden layers we have, the more complex pattern the model can learn, right? So human brain, if I talk about the analogy of human brain, let's first understand why this picture of human brain is shown over your left hand side of your screen. Okay, our brain contains billions of biological neurons connected together. So whenever we see something, for example, a cat, our brain processes different features like eyes, ears, shape, and color before recognizing it. So deep learning tries to exactly imitate this process by using the artificial neural networks, right? So instead of biological neurons, which is there we have, we as a human brain, we use mathematical neurons. Instead of electrical signals, we use numerical calculations in deep learning. This is why neural networks are often inspired by the human brain. If I talk about the simple architecture of neural network, every circle represents an artificial neurons. You can see I'm talking about these circles. Okay. Every connecting lines represents a weight. Weight. Yeah. WEIGHT. Right. So these weight decide how important each piece of information is. The information flows from left to right. This is your left side. Information, like let us say you are looking at the cat as a human being. Similarly, consider that your machine, your system is looking at the cat, picture of the cat, and then it starts from here. And that's what I said, left to right. So the information is flowing from here to here. Okay, left to right, I mean to say. The first layer is called input layer. I have mentioned here after the pattern recognition. Okay, we have the label data, like I said, the cat. Okay, then the first layer is going to be input layer, right? So then what happened? The data process is happening like the data is passing through multiple hidden layers. So multiple hidden layers are there that you can see in the picture. Finally, we get predictions from the output layer. So after that, so many things are happening with this layer, with input layer. natural language processing coming into the picture, computer vision is coming into the picture. It is generating the model, and then you get the answer, the output that it is a cat. So this is how your neural network, your deep learning concept is going to work. Let me just tell you one more thing. Input layer. Okay, so the input layer receives raw information. For example, if we are recognizing handwritten digits, right? So the input could be thousands of pixel values. If we are analyzing customer information, the input could be age, salary, location, and purchase history of a customer. So the input layer simply receives the data, nothing else. Okay. Coming to the next layer called hidden layer. Okay. So these are the most important part of deep learning. Make sure viewers, learners, you are able to understand. If in case you are not, please let me know in comment. I will definitely give you clear explanation. So every hidden layer learns increasingly complex features. Let's understand this using face recognition. Hidden layer may detect edges. Hidden layer, the one, two, if I'm giving the numbering, then let's say we have one more hidden layer, one more layer is there inside it. Second layer, it is detecting the eyes. The other one is detecting the nose. I'm taking the example of cat only, let's say. The fourth layer is detecting the, complete face. So, in short, if I explain you, if you are catching something or you are having a labeled image of cat, so how hidden layer understand? Input layer is just receiving the input, but hidden layer is how it is understanding. The layer one is detecting the edges. Layer two is detecting the eyes. Layer two is detecting noses or extra features. And finally, layer four is recognizing the complete feature. So each layer build upon the previous layer. Okay, that means one layer completed, then it goes to the further layer, and then final analysis is giving us the final result. So this automatic feature learning is what makes deep learning so powerful. Right? Coming to the output layer. This is output layer. So finally, the output layer gives us the prediction. For example, cat, I said. So the images of cat or dog, other mail is spam or not spam. The review is positive, negative, or neutral. Okay, disease detected or not. The output depends on the problems we are solving. I mean, if it is a, medical or healthcare system, then the diseases detection or not detection is fitting as an example. If it is e-commerce website like Amazon or Flipkart, then positive and negative reviews or neutral reviews are fitting as an example. Spam or not, it's for the mail also, you can say, like on Gmail we get spam mails. Yeah. So that is your output layer. So in output layer we actually get the answer, right? Let's understand something called pattern recognition. I have spoken about the input layer. I've spoken about the hidden layer, and I'm talking about the this layer. This is the output one. I have not spoken about this generative model, computer vision, natural language processing, pattern recognition. Let me just break down them into one by one. So one of the biggest strength of deep learning is pattern recognition that you can see here. Friends, it learns hidden patterns from huge amount of data. For example, detecting fraud in bank, recognizing the speech, predicting diseases, stock market analysis, recommendation system, and much more. Okay, so pattern recognition is coming into the picture when it is learning hidden pattern from the large, or you could say huge amount of data. Next, natural language processing. Another important application is natural language processing. In previous video also I have explained about it, but it is commonly known as NLP. So here deep learning helps computers understand human language. All right. Let's say for example, ChatGPT, Google Translate, voice assistant, so many voice assistants are there. email spam detection, sentimental analysis, text summarization, Google Translate. So many like language translation. So whenever computers understand or generate text, deep learning is working behind the scene, and that is through the natural language processing. We call it NLP. The next one, coming to computer vision. Computer vision allows machine to understand images and videos. Okay, like for example, if I say face on smartphones, right? So your through your face, your smartphone is getting unlocked. That's nothing but your computer vision. That's the application of computer vision. So it is allowing the machine to understand images and videos, right? Self-driving cars are there, medical image analysis are there, object detection is there, license plate recognition is there, security surveillance there. So your deep learning learns visual um, features automatically. Okay, let me give you one example. Just imagine that we have a video. Okay, I will be giving the examples with codes and certain libraries also in future where we can practically perform it step by step. But as of now, for your understanding, let's say we have a very small video in that two people, one male and one female. They both are dancing and their faces are like and we want to detect their face. So sometimes they are turning left, sometimes they are turning right, sometimes up, sometimes down, sometimes, since they are dancing, they are not still. So in that scenario, if we have to recognize the face, recognize or just detect the face. Okay, so this technique called computer vision works with that. So it is actually internally how it's working. We have trained with the algorithm that yes, these are the features of face. So wherever in the picture, in the video, it is detecting that features, it is going to consider it as a face. Like in Facebook, a real time example, sometimes when we have a group pictures, we have gone for a trip and we are uploading a group picture, we are posting a group picture, it is actually making a circle, or you could say rectangle, on everybody's faces by asking you who is that. So if you want to tag people, you can tag. That's again the application of deep learning and the part of computer vision. Coming to the next part, that's called generative model. So this section represents generative models. Unlike traditional models that only classify information, generative AI is creating completely new content. For example, ChatGPT generates the text, Delay generates the images, GitHub Copilot writes the code, AI music generation is there, AI video generation is there. I mean, what do you say? These systems learn pattern from existing data and generate brand new content. Let us say, for example, I am giving two PDFs. I'm training the machine or model with two PDFs. Okay, and in both the PDFs, there is kind of similar explanation about computer vision, natural language processing, pattern recognition, and deep learning is mentioned. Now I'm going to AI like ChatGPT, and I'm asking that. I mean, it has been trained with two PDF. You have to just assume. So what it does, it actually doesn't give you exactly what it has been trained with, but it checks both the PDFs and it finds the best one and it generates the good one for you. It is not same as it has been taught. It's not the same copy it is passing it to you, right? So that's something called generative AI and generative model. Right. Next, I have used two more things here, labeled and unlabeled data. Let's talk about that. When I say labeled data, so label data means I have already explained you in previous session, but it means like every training example already has the correct answer. That means the question and answer are already given. For example, image is animal image is given and dog is written. Similarly, image is given, cat is written. Email is given and it's there in the spam folder already. And or maybe not spam. So this type of learning is called supervised learning. And the model compares its prediction with the correct answer and gradually improves. That's we do with the label data. So supervised learning is always with the labeled data, right? Let's come to the unlabeled data. Unlabeled data contains only input data without correct answers. For example, thousands of customer images are there, millions of documents are there, large collection of videos are there, and the model tries to discover hidden patterns on its own. So this is commonly used in unsupervised learning and self-supervised learning. In further video, I'm going to talk about self-supervised, which is a very important concept to know nowadays. So modern foundation models often begin learning from large number of or enormous amount of unlabeled data before being fine tuned with the labeled data, right? So why overall I have spoken about everything. So if I say why deep learning, then so why everyone is talking about deep learning? Because it can learn features automatically, handle huge data sets, improve accuracy, solve complex problems. It is powering modern AI application. It understands the image, right, and understand the speech as well. It always generate the text, handle huge data set, improve the accuracy, solve complex problems, power modern AI application. So it is writing the code and generating the image also, like you already have experience with ChatGPT. So this is why
deep learning is considered the backbone of modern artificial intelligence. If I give you some real world example, Netflix is recommending movies using deep learning only. Okay, so recommendation system you must have heard, but and how, why, when it is doing everything we all are aware. But how, what is the exact technology? What is the exact type of AI it has been used? That is something you can say. It has been the recommendation has been taken care by deep learning. Also, same on Amazon e-commerce website, you go and you get the recommendation of products again using deep learning. Okay, Tesla is recognizing roads and obstacles through the deep learning. Google Photos identifies the faces. Same. ChatGPT generates human-like conversation. Deep learning. Healthcare system detect diseases from X-ray. Again, deep learning. So banks are identifying the fraud transaction. So these all are practical applications of deep learning. Let me quickly give you a recap. So deep learning is a subset of machine learning. It uses artificial neural network inspired by the human brain. Data enters through the input layer. Hidden layers automatically learn important features. The output layer produce predictions. And deep learning power pattern recognition, natural language processing, computer vision, and generative AI. It learns from both labeled and unlabeled data depending on the learning approach. I hope this video helped you understand the basics of deep learning. In the next video, we will dive deeper into the artificial neural network where we will explore neurons, weights, biases, activations, functions, forward propagation, and backward propagation with the practical example. If you found this video helpful, don't forget to like, subscribe, and share it with anyone who wants to learn AI, machine learning, and deep learning from scratch. Thanks for watching. I will see you in the next video.